Yeah. So we'll try to see the deflection of beams. In this deflection of beams, how many methods you know, guys, for finding the slopes and deflections? How many methods do you know? Means, are you aware of the methods to find the deflection and slope of the beam? Yes. Basically, we have seen this shear force and bending moment diagram, right? In previous classes, we have seen section 4. Actually, there was, Naveen sir facing some issue regarding this electricity. So I'm just covering the, today's session. Maybe tomorrow he will be covering instead of me. Yeah. Now, so suppose we have seen the shear force and bending moment diagram for, let's suppose that I am drawing the cantilever beam. And let's suppose that there is a load which is acting at the mid end. Now, if I'm asking you, what will be the shear force? Yes. What are you saying? I'm lagging in the previous class. It's no problem. Already you attended the class, right? For the GATE exam. You already attended the class, right? Yeah. So you can just attend this particular class because shear force and bending moment diagram, I think you are aware of those things. Now, so now if I just take along the cross section XX, what will be the bending moment on that XX? Minus PX, right? It's a hogging bending moment, right? It's a hogging bending moment, right? Yes or no, guys? If I take along the x-axis, whatever the cross section XX will be there. If I take the bending moment, the bending moment will be minus P into X. That means it will try to bend this beam something like this. Like this. Now, if I'm going to draw, you have drawn shear force diagram and bending moment diagram. Now, right now, I'm going to show you the elastic diagram, elastic curve. This will be, my dear friend, elastic curve. Where exactly at this point, suppose I'm taking the point B, here also I'm taking the point B. The deflection is going to be maximum. Here at point A, slope at A will be 0 and deflection will also be 0, right? Because of the fixed support, there will not be any vertical deflection. Yes or no, guys? Now, in whole beam, if I'll be asking you where we are going to have the maximum slope, what you will say? You can say that the maximum slope we are going to have at the B point. Sorry, deflection and maximum slope also there itself. See, as you can keep on moving, the slope is keep on increasing and it will increase like this. It will increase, something like this. Right? So this will be the, conditions. This will be conditions. So with respect to x-axis, positive x-axis, I am measuring the angle theta b in the clockwise direction. The sine convention to be considered positive or negative, that means clockwise rotation to be positive or clockwise rotation to be negative, that will depend on the sine convention of the deflection. The sine convention of the deflection, right? So note down one point. The sine convention for slope will depend on sine convention of the this deflection. Why I'm saying this to be condition? Suppose you are assuming this to be positive. Suppose you are assuming downward deflection to be positive. Suppose, for example, the downward deflection you are considering this to be positive. Suppose you are considering this to be, positive. You are considering this downward deflection to be positive. In that case, what will be the tan theta b? In that case, what will be tan theta b? YB minus YA divided by XB minus XA. Yes or no, guys? Check it out. The slope value we can calculate YB minus of YA, YB minus of YA. We can take this small angle theta b. When theta b is very, very small, tan theta b will be equal to what? Theta b only. When it is positive, this is also going to be positive. That means clockwise rotation is going to be what? Positive. Clockwise rotation will be positive. Suppose you are taking YB, downward deflection, to be negative. In that case, clockwise rotation will be negative. Understanding my point? Of course, in the GATE examination and other examination, the sign will not matter for this particular deflection and slope finding, right? As for the beams is concerned, for finding the deflection and beams, slope and deflection for the beam, do not worry about the sign convention. They are asking only magnitude. Yes or no, guys? But most of the students having the confusion in the sign convention. When it is downward, sir, positive or negative. If you are taking the negative, the slope, whatever the rotation is there, clockwise rotation, the clockwise rotation of the beam will be considered as positive. Suppose you are considering the downward deflection to be negative, then whatever the clockwise rotation will be there, that is negative only. Suppose vertical deflection is there, then anti-clockwise rotation will be positive, and upward deflection will be what? Positive. That also all depends what sign convention you are calling for deflection, vertically upward or vertically downward, whether it's positive or negative, right? Yes or no, guys? Means upward direction, you are considering this to be what? Suppose you are considering this to be negative, then anti-clockwise direction will be what? Negative in that case, right? That is what the conditions. We'll try to see one problem. With that, it will be clear. Now, once it is done, let me know. Done, all of you? All of you done? Perfect. So very first question we are going to see, is that question number 1. So today we will try to solve at least 10 problems, right, in the classroom itself, so that it will be most of the things will be getting clear. Whatever the doubts you might be having while calculation for the slopes and deflection, that will be clear. A cantilever beam which is subjected to point load P, a beam which is having a length of L. Now they are asking what is the slope and deflection at B point. They are asking what is the deflection and what is the slope. They are asking these things. Very, very simple. A cantilever beam subjected to point load. So what is the name of this beam? A cantilever beam with point load. A cantilever beam with the point load. So it's a very simple. The first method which I'm going to tell you is double integration method. The first method I'm going to follow is, note down, double integration method. Note down what is the double integration method? EI into d square y by dx square will be equal to minus of mxx. Mxx means bending moment. This is your bending moment at that particular cross section. Bending moment at XX cross section, XX section, you can say. Now, if you follow this formula will be valid under sign convention. Predefined sign convention will be there to use this formula. Note down what is the sign convention. It's a very, very important. If you use this formula and suppose you are getting the y value to be downward, you please consider this to be positive. You please consider this to be positive. Theta value, when you are getting clockwise rotation, suppose theta value you are getting positive. Suppose theta value you are calculating and you are getting suppose positive value. Please consider clockwise rotation from x-axis. Very, very important, guys, sine convention. One of the major problem that students face with this particular thing. Now, why we are following this sine convention? Because while using this sine convention, we are getting this particular formula. That's the reason we are using this sine convention, right? Now, if somebody very much interested, they can either read BC Punamya or they can join the course for the GATE examination, right? Whatever in the GATE course will be there. In detail, we are going to learn each and every derivation also, right? So, very first method is what? Double integration method. How many of you know are aware of this particular method? This is a very basic method, and I might be sure that you have studied this thing in the BTech also. This particular first method, if I am correct. Double integration method. So first of all, we are going to find the bending moment at xx particular section at a distance of x, where x is taken from B point. Tell me, guys, how many of you are aware of those things? Minus w into x, right? Minus w into x, right? Because if you follow the sine convention, if you follow this sine convention, you are going to get what? Negative. Tell me, guys, are you able to follow me? Because it is creating hogging bending moment, right? That's why it is negative. I hope you people are understanding. All of you are understanding what I'm saying? Correct. Now, try to understand. After this one, there is a one important thing that we need to keep it over there in the formula. EI d square y by dx square, that is equal to minus of m into xx. That will become what? Minus, sorry. Minus and minus will become plus. Minus and minus, this minus and this minus, already there with the formula, that will become plus. Now do the integration. Ey into dy by dx, that is equal to w into x square by 2 plus c1. Again do the integration. So Ey into y, that is going to be w by 2 into x cube by 3 plus c1x plus c2 plus c1x plus c2. That is going to be your major formula. Now, how to calculate C1 and C2? That depends on the boundary condition that we are going to see. Right? What are all the boundary conditions you are going to get it? Tell me, guys. What are all the boundary conditions? What is the first boundary condition? At x equal to L, theta A will be 0, right? And at x equal to L, ya will also be 0. Check it out. All of you, please check it out. All of you, please check it out. Whatever I said, correct. So note down quickly and let me know once it is finished. Done, all of you? Is it done? Perfect. Perfect. Now try to understand. So what are all the conditions we got it? Ey into y, that is equal to, my dear friend, that is going to be equal to w into x cube by 6 plus c1 into x plus c2. At x equal to L, theta will be 0 first of all. So what is the theta formula? Ei into dy by dx, that is equal to w into x square by 2 plus c1. Put the value. This is going to be 0. So this is 0 equal to what? W into L square divided by 2 plus C1. So what is the C1 value? Minus W into L square by 2. That is the very first boundary condition. Second boundary condition, this is going to be 0. And when this is going to be 0, W into L cube by 6 plus C1. What is the C1? W into L square by 2 into L. Because at x equal to L, Y will be 0. At x equal to L, Y is equal to 0. Because fixed support plus C2. So from here, what is the C2 value? WLQ by 2 minus W into LQ by 6. So C2 value will be 6, 3 minus 1, 2, WLQ. So this is going to be W into LQ by 3. Now put the value and get the answer. We need to calculate slopes and deflection at x equal to 0 itself, at the point B itself. Then what is going to be answer? Theta B. Theta B. Theta B will be at x equal to 0. At x equal to 0. Then what you see, dy by dx is what? Theta. Some of you might be confused, sir. Why dy by dx will be 0? Theta. Theta will be called as dy by dx. Slopes. Right? Now, C1 value. What is the C1 value? Minus W into L square by 2. Minus W into L square by 2. Right? This is going to be theta B value divided by EI. Please note down, very important. Very, very, very important. Done. Now, so this is the slope, maximum slope formula. What is the maximum deflection? At x equal to 0, YB will be. This is going to be 0. This is going to be 0. C2 value. What is the C2 value? W into LQ divided by 3EI. This EI will transfer to the right hand side and this will become the formula. That is what the maximum deflection formula. Maximum deflection formula. Note down, very, very important. Highly important. Now, once it is done, please let me know. Done, all of you? Is it done? Perfect. Perfect. Now, same problem I'm going to discuss. Same problem I'm going to discuss with the second method. There is a W load that has been acting. Again, I'm going to take the same length. Same length I'm going to consider. Now I'm going to follow the second method. I'm going to follow the second method as moment area method. Moment area method. Note down, very important. Moment area method. According to this method, note down what is so special about this method. Note down what is so special about this particular method is that whatever the the difference of the slope formula, will be the area of bend. See, for knowing this method, you must be able to understand the bending moment diagram. That's why I focus so much on shear force and bending moment diagram, right? So note down the formula. Suppose this is the point B, this is the point A. Theta B minus theta A will be area of M by EI diagram between B and A. Note down area of M by EI diagram between B and A. Very important. Area of M by EI diagram between A and B. Now, done all of you? Now, how to find the deflection? YB will be YA plus, theta A into the distance between A and B plus or minus B deflection of B with respect to A. This is the formula we are having for finding the deflection, where this value will be what? The moment of area of M by EI diagram between B and A with respect to B. Now, once we understand these things, then you will understand the whatever the moment area method is statement. So this is the statement number 1. You can say formula number 1, and this is the statement number 2. All of you are getting my point? What will be the bending moment diagram, guys? What will be the bending moment diagram? Can I say this M by E? This is a M diagram. This is nothing but M diagram. But I need to draw M by EI diagram. This is the bending moment diagram where bending moment is what? Minus W into L. But I need to draw my different M by EI. Now, once I divide with this M with the EI, my diagram will look what? My diagram will what? My diagram will be what? Reduced. My height of the diagram will be what? Diagram height will be reduced. Yes or no, guys? Please check it out. This is the what? The bending moment diagram. Now, once you draw the bending moment diagram, suppose we need to find theta B minus theta A. Suppose we need to find theta B minus theta A. We can easily determine, very comfortably we can determine. Just take the area. What is the area? Height into distance. Height into distance. What is the height? Minus of M by EI into height. Sorry, into length L. So now what is the theta? 0. So simply theta B will be minus ML divided by EI. And what is the M? What is the M? Minus W into L. Sorry, W into L square divided by what? Sorry, guys. Whatever the bending moment diagram you are drawing, that is incorrect. There is no concentrated movement. How can you say that this will be correct? And nobody responding also. Nobody responding also. Yes. The diagram will be triangle 1. Yes or no? Bending moment at the free end will be what? 0, because there is no distance. Right? So this will be my M by EI diagram. Suppose that this will be my M by EI diagram, where M is nothing but minus W into L. Right? So now this is the bending moment diagram. What is the theta B minus theta A? Take the area of this bending moment diagram. What is the area? M by EI into what? L. So now theta B, half of M into M by EI into what? Length. Half of base into height. This is 0. So this theta B will be what? M is what? W into L square divided by 2EI. Check it out, all of you. All of you, please check it out. Are you getting the same slope or not? Done, all of you? So noting down the bending moment diagram and knowing the bending moment diagram is very much essential. All of you understanding the importance of shear force and bending moment diagram? Yes? Correct. What will be the second statement and how we can determine the deflection? That is what very, very important thing. So deflection B will be, we need to find at the point B, we need to find at point B. Point A, deflection will be 0, slope will also be 0. Directly delta B with respect to A will be the formula for YB. Now whether it is a positive or negative, that is what the matter of concern. So that will depend on the elastic curve. Let me show. Now, do not worry. I will come back to that particular slide. I just want to show that elastic curve for this particular beam. Elastic curve will be something like this. Now, try to understand. This is the point B. This is the point A. The slope here at point A will be 0. Slope here at point A will be 0. And deflection at point A will also be 0. That is the first thing we know. But at point B, suppose we need to find the deflection. Suppose we need to find the deflection at point B. Now, at this particular point, if I draw the curve, where exactly it is going? Exactly, if I draw the tangent at point B, where exactly it will go? Tell me, guys. Where exactly it is going to be going? Something like this or not? Right? Tell me, guys. Now, let me just show you one more diagram where simply supported beam is there. And now the deflection will be, suppose that like this. Now, suppose at point B, if I'm just taking A point is there, B point is there, C point. Try to understand. Just wait. I will make you understand each and everything. Just wait. Now, if I draw the point B, if I just draw the tangent from the point B, if I draw the tangent from the point D, now, so here, suppose that at point D, suppose if I want to calculate, or we can say that, yes, suppose I need to find for simply supported beam exactly at this point, I need to find the slope, a deflection. So how we can find YC? Suppose I'm calculating with respect to D. How we can calculate? YC will be, total YC will be, total YC deflection will be YD plus, how we can determine this thing? Theta D into length, distance between C and D, right? That will give me total this one length. This YC dash will be this one YC dash. Yes or no, guys? All of you are understanding what I'm saying? YC dash, we have calculated YD plus theta D into LCD. Check it out. That will give me total height, YC dash. If you're not understanding, please let me know. This will be total distance. But I don't want YC dash. Remember, these are the most frequent doubts and mistakes in many of the sources. That is my guarantee. If you just follow any textbook, a lot of mistakes are there in that. Particular conceptual mistake is there for explaining this deflection formula, right? I know we have the double integration. I know we have the Castigliano's method. I know many methods are available. Believe me, moment area method is one of the most simplest method you will ever find for the cantilever beam. Right? Now, I need to find this particular distance. For finding that distance, for finding this green color distance, my dear friend, I need to subtract this thing, and this is called as minus of delta C with respect to D, and that is going to be calculated is nothing but area of moment diagram, sorry, just wait. This is nothing but moment of bending moment diagram area, bending moment diagram area, Bm by I, bending moment diagram area with respect to point C. Now, why we are doing minus sign? Because we need to subtract it. Sometime we need to add it. Sometime we need to add it. Something like this. Now, if you just able to follow me, suppose we want to calculate with respect to A. Suppose we want to calculate with respect to A. So there is no problem. There is no problem. We can draw the slope. We can draw the slope. We can draw this. Of course, in this particular case for the cantilever, if you are taking with respect to point A, do not worry about the plus or minus because automatically that is 0. YB will be YA plus theta A into what? LAB. And what is that value? Plus or minus? Now tell me where it will be, where here it will be plus or minus. Here it will be plus or minus. Here I just show you with a simply supported beam, it should be minus if you are taking with respect to point D. If you are taking with respect to point D, we need to just subtract it. Now we cannot add it. We cannot add it, my dear friend. That is what the main important points. Please check it out. All of you, please check it out. Suppose you are calculating YB with respect to point C, theta C, YC is there, YB is there. But this is what YB is there. Sorry, this is what we have YB. This is what we have YB. Let me show you when we can consider +1 and when you can consider the -1, my dear friend. This is total YB. This is total YB. And this is what we have theta C into LCB. Now we need to calculate this also. And this distance is what? Plus delta B with respect to C. Are you getting my point? When to take plus, when to take minus? The distance between the slope diagram from the other point, the distance between, this is nothing but what? The distance between the slope or tangent drawn from the other point to the point on the elastic curve where we need to find the deflection. Understood? Let me write. The distance between point on the elastic curve at point where we need to find the deflection where we see the distance between the point on the elastic curve at a point where we need to find the deflection, and one more point, the tangent drawn at other point. See, whatever the tangent we have drawn, this is my elastic curve. Try to understand, guys. If not, please let me know. I will make you understand one more time. This is the point C. If I draw the slope diagram, slope of this one, if I draw the tangent will not be same as point D, guys. Please remember, this is the elastic curve. This is not the curve which is a straight line. See, this curve has been drawn like this. So whatever the slope at point C and point B will be different. Here the slope is what? Like this. Let me show you. Here the slope at the point C will be like this, and slope at point B will be like this. All of you understanding or not? All of you understanding or not? Tell me, guys, both are different. Both the slopes are different. Yes or no, guys? Yes. Now, so whatever the hard work we are doing right now, that will be fruitful. Believe me. Believe me, guys. Just believe me. Have patience. Now, so that is what the one thing. Now, second thing is that when the slope can be same, that is what the question mark. Like this. When suppose that there is a no elastic curve, right, between the point C and point B, it is a straight line, just a straight line. In that case, point C slope and points B slope will be different by different, will be same. In that case, we can easily determine simply YB deflection will be YC plus theta C into LBC, and that delta B with respect to C will be 0 in this case. Please note down 3 cases where it is positive, where it is 0, and where it can be negative. Please note down, very important. Most blunder mistake ever done by many sources while explaining this moment area method. Please note down, especially this deflection part, very, very important. This is the correct method. This method has been given among in the all the standard textbook. Not believing, you can check it out. Please note down, very important. Now, once it is done, let me know. Is it done, all of you? Done. Shall we back to the problem? Can we back to the problem? Perfect. Now, so here if you just try to see, my dear friend, here if you just try to see, whatever the slope diagram will be there, whatever the elastic curve diagram will be there, like this. Now, so here if you just say the point A and the point B, the slope is 0 exactly, nothing is going to be there. So whatever the distance will be there, that can be directly calculated with respect to delta B with respect to A. And you know that what is this? What is this? I already mentioned moment of area of M by EI diagram between B and A with respect to B. Just take the area first of all. Note down the area. What is the area? Half of base into height. Half of base into height and moment. This area moment, the distance between the centroid and B point. That is what the meaning of moment of area. And what is this distance? 2 by 3 into L. Check it out. All of you, please check it out. This 2 will cancel out. M is what? W into L. So W into L cube divided by what? 3EI. Forget about the minus or plus. Just focus on the magnitude. All of you, please check it out, whatever I want to say. Yes, done. Perfect. Shall I give the question? So we can solve one more problem of simply supported beam, right? With this method, we can solve one more problem. Suppose there is a simply supported beam. All of you want to try this particular method because it's an easy one. Only you need to draw the bending moment diagram. That's it. Understanding my point? Only you need to draw the bending moment diagram. That's it. The first method is what? Double integration method. That is very lengthy method. Very lengthy method. And of course, one more drawback is there. That double integration method will be useful when we have the constant bending moment. Sir, what is the meaning of this? I will explain you. Each and every method will be having pros and cons. First of all, you need to understand this thing. All of you want to try this question? All of you want to try this question? I'm asking you theta c. I'm asking you YA and YB, of course, both will be same because of the symmetricity. And what will be the nature of the diagram? Elastic curve. Elastic curve will look something like this, where the slope, of course, will be maximum at the point A and point B. At point C, the slope will be 0. There's no doubt. So because I just asked you randomly, you can just find. And what is the maximum slope? Maximum slope, of course, for the symmetric loading condition will be theta A, that is equal to theta B, and that you need to find. So for this, I'm giving you option A. Let me check. Yes. W into L square divided by, 24 EI. L square divided by what? 8 EI. W into L square divided by what? 16 EI. 16 EI. WL square divided by what? 48 EI. All of you, please tell me the answer for slope. Maximum slope. Take your time. Do not hurry. And just tell me the answer. Option D. Option D or option C? Now try to see. We are going to solve, the correct option will be C. How? Just check it out. Please check it out, all of it. It's very important. So very first of all, we need to follow slopes and deflection. And what is the answer for slope? What is the answer for deflection? Same answer, but just replace L square with L cube. Try to solve. All of it done? Hello guys, is it done? So whatever the area, suppose you are taking any 2 points, you just take the M by EI diagram between those 2 points. That's it. That's only the difference. Understanding or not? Yes or no, guys? Yes. Correct. Can I remove this all? Can we see the deflection part? Perfect. Now try to understand the deflection. That is what we are going to see. Now the same problem I'm going to take. The simply supported beam which is subjected to the point load. The simply supported beam we need to take, and which is being subjected to the what? Point load, and the bending moment diagram will be looking something like this. The bending moment diagram will look something like this, where the maximum bending moment will be what? WL divided by what? 4EI. Now we need to find the slopes, deflection at the point C, where it is maximum deflection is there. That we can find, suppose with respect to A. I'm taking with respect to A point, YA plus theta A into distance will be what? Distance between A and C will be L by 2, L by 2, L by 2, L by 2, L by 2. And what will be the final value? Sorry. What will be the final plus delta B plus delta C with respect to A, or minus delta C with respect to A? That is what the question mark. What I said, what is the definition of delta C with respect to O, or delta any point with respect to any other point? What is the definition? I said that. Just check it out. The distance between the point on the elastic curve at the point where we need to find the deflection and the tangent drawn at other point. The tangent drawn at other point, and the distance, this particular distance will be called as, my dear friend, delta C with respect to A. And that is going to be negative or positive. That is going to be negative or positive. All of you, please let me know. Only the Y maximum will be till this part only. But unnecessarily this delta C with respect to A is what? Added over there. So we need to subtract it. Understanding, all of you? See, YA will be 0. Deflection will not be there at the hinge support. It is going to be restrict this vertical movement, my dear friend. That's why the deflection will be 0. And whatever the slope will be there, this is the total height. And we need to subtract this particular height, so that we'll be getting what? Deflection at point C. Exactly. And that is what? Y maximum. Check it out. All of you, please check it out. And what is the slope? Slope is what? W into L square divided by what? W into L square divided by what? 16EI. Now, do not confuse capital L and small l, both are same thing. Delta C with respect to A is nothing but the moment of area between the moment of bending moment diagram between the C and A. The moment of bending moment diagram between C and A. First of all, we need to find the area of bending moment diagram. What is the area? Area will be half of WL divided by 4EI into L by 2 into the distance. Moment we need to take. Moment. Force into distance. Area into distance. That would be called a moment of area. So what is the distance? L by 3. From the base, L by 3. So L 1 upon 3 into L by 2. So that is what? L by 6. All of you, please let me know. If not, then there might be difficulty you will be facing in this particular method. Tell me, guys. All of you are understanding or not? All of you are understanding what I'm saying? Please check it out. Very, very important. Done. That will be the answer for the deflection. That is going to be answer for deflection, my dear friend. That's a very, very important thing. That's a very, very important conclusion we can draw. Is it done? Perfect. Now, note on the question number 3 or note on the formula. The formula is going to be very, very important for you guys to remember the formula. Formulas are going to be very, very important. So this method will be easy when the bending moment diagram is easy. When the bending moment diagram will be parabola, we need to find the area of the parabola in that case. Very first case will be this thing. The moment I'm going to apply for the length L, note on the formula, slopes and deflection. Theta B will be ml divided by EI, and deflection will be ml square divided by 2 EI. The second case will be WLQ divided by 3 EI. Third case will be cantilever beam, which is subjected to uniformly distributed load. The length will be suppose L. Then what is the slope? WLQ divided by what? WLQ divided by what? 6 EI. Now some of you might be thinking, start thinking, sir, why it is LQ? Why it is L only, L square only? Here it's a W Newton per meter. Here it is Newton. Check it out. WL power 4 divided by 8 EI. The fourth one I'm going to consider, my dear friend. Again, I'm going to take the cantilever beam, but there will be kind of UDL load. Suppose in this case, there is a UDL load I'm going to draw. Suppose UDL load. So here the slope and and deflection will be W into LQ divided by 24 EI and 5 WL power 4 divided by what? 384 EI. Note down, very, very important. So I have written this cantilever beam case at one particular time so that you can remember, just like a shortcut. Many PSU examination, in most of the cases, they are asking directly the values, the formula, directly giving the 4 options, and they're checking whether you are knowing or not. Is it done? Done, all of you? So number 4, what do you mention? Number 4 formula are for UDL on simply supported beam. Number 4th one, yeah, correct. So there is a slight mistake is there. Now it's fine, right? 30 is there, right? Done, all of you? Yeah. So thanks for the correction. It's 31, not 5 by 384. Done, all of you? Note on the 5th formula. A simply supported beam subjected to the movement. A simply supported beam subjected to the movement, suppose like this. Right? Then what will be the maximum value and maximum slope value? Maximum slope and maximum deflection formula will be ML divided by 2EI, and deflection will be ML square divided by what? 8EI. Simply supported beam subjected to point load at the middle section of the beam, where theta maximum will be WL square divided by 16EI, and Y maximum will be WLQ divided by 48EI. Very, very important, note down. This seventh one will be a simply supported beam is there. Now there will be uniformly distributed load. Suppose it is being subjected to the uniformly distributed load, then the formula will be W into LQ divided by what? 24 EI, 5 WL to the power 4 divided by what? 384 EI. Eighth one, just note down, for fixed support at both the ends. Now it is being subjected to the uniformly distributed load, so there will not be any slope. So we are not writing any slope formula. Nothing is there. Note down directly the formula for deflection. Maximum deflection will be W L to the power 4 divided by 384 EI. Note down, very important. So these are the formulas that will be very important. One more formula, note down. A fixed support which is being subjected to both the fixed supports are there. A beam subjected to both the fixed end and subjected to the point load. Y maximum will be W LQ divided by 192 EI. Very important. Very, very important. Once it is done, let me know. Done, all of you? Perfect. Now we'll try to solve the problem. Different problem by different methods we are going to see. And let's see how we can just proceed with the problems. So very first problem I'm going to take. Okay. So we have the question from the slides. Directly we can take it out. Yeah. So very first question I'm going to see. The basic equation of deflection for any beam represented by something like this formula. This one particularly formula we have already seen, where EI is nothing but flexural rigidity and M is nothing but the bending moment. Then what is the EI d cube y divided by dx cube? What we call EI into d square y by dx square is equal to bending moment. Again, if I differentiate, I will be getting what? Shear force. Very good. A option will be correct. Again, if I differentiate, what I will be getting? df by dx, and that is what my loading diagram, my loading one. Very important. Done. What is the answer for this question? A cantilever beam subjected to uniformly distributed load of the whole length. What is the downward deflection at the free end? What will be the downward deflection at the free end? It's a very simple. It's a very simple. What will be the answer? A. Note down, very important. Done. Perfect. Try to solve this question and let me know the answer. A cantilever beam subjected to a concentrated load at a distance of L by 3 from the free end. Suppose total length is L. The cantilever beam subjected to point P at a distance L by 3 from the free end. What is the deflection at the free end? Suppose this is the point B, this is the point C, this is the point A. They are asking what is the deflection at the point C. The load has not been acted at the point C. They are asking what is the deflection at point C. Very easy. Very easy. So you can solve by the bending moment area method. You can just solve it by the moment area method. For that, you need to draw the bending moment diagram. You need to draw the bending moment diagram, something like this. You need to draw the bending moment diagram, something like this. What's happening? So P into 2L by 3, this will be my bending moment at the point A. At the point B, 0. At the point C, 0. That's it. That's a very simple thing. Now, my dear friend, we need to find the bending moment at point C with respect to point A. Deflection at point A is equal to 0. Theta A, the distance is what? L. The distance is what? L. The distance is what? L plus delta C with respect to delta A. This is also 0. So YC value will be, what is the slope, what is the moment of area of bending moment diagram? What is the slope of, sorry, what is the moment of M by EI diagram between, what is the moment of M by EI diagram between B and, C and A? That's it. So first of all, we need to take C and A. That means C to B, there's no, nothing is there. C to A, what is the area? Area will be this area only. Area will be this area only. What is the area? Half of PL, 2PL divided by 3 into distance, height into base, that is 2L by 3, 2L by 3. And what is the distance? Distance from here to, we need to determine the slope. Where we need to find the deflection, sorry. Where we need to find the deflection. So here it is what? From here to here it is what? H by 3 or B by 3. Base by 3 means what? 2L by 3 by 3 plus L by 3. Yes or no, guys? 2PL square divided by 9. This will be what? 2L by 9 plus L by 3 into 3 into 3. So it will be what? 2PL square by 9, 5 into L divided by 9. So 10 divided by what? 10PLQ divided by what? 81 EI. Of course, you have the what? 1 upon EI also. Because not only you need to find the moment of M by EI diagram, sorry, not only you need to find the moment of M diagram, you need to find the moment of M by EI diagram. And that is going to be what? EI will also be coming. So no option is matching. Why there's a no option? Check it out. Any mistake with it? Sorry, the distance will be 2. The distance will be 2 by B by 3. Suppose This is the suppose this is the triangle we have. What about suppose this is the total base? Then what about this? 2b by 3, right? Sorry, there is a mistake, small mistake, guys, that you can just correct it. Into 2. Into 2. Sorry. So here it is not 5L. It will be what? 9 plus 3, 12, right? Four, 7, I think. So this will be 14. Check it out. All of you, please check it out. All of you, please check it out. Understanding what I'm saying? All of you are understanding what I'm saying? Not able to find? Shall I explain once more time? Can I explain you one more time? All of you are getting my point or not? Yes? Yes or no? Tell me, guys. Correct. So a small mistake. This particular distance will be 2 by 3 of this 2L by 3 plus this one L by 3. That's what the distance from here to here, right? Now, some of you who might be very much curious to know about the some how we can solve this by another method, right? So let me show you by different. No, one more method is there, so that we can find same question I'm taking. Same problem I'm taking, and I'm going to solve this question by Castiglione's method. Note down the method number 3. Castiglione's method. Note down Castiglione's method, guys. It's a one of the most important method. This method is also called as strain energy method. Note down this method is also called as strain energy method. Very, very important. According to this method, let U be the total strain energy of the beam and strain energy formula is what? U will be m into xx whole square dx divided by 2ei from 0 to L. Suppose from 0 to L. That will be the strain energy, my dear friend. Now, according to this theorem, the slow value at any point dou u by dou m. Suppose movement is acting at that point A. If you want to find the slope at that point, differentiate with respect to that movement and you can find the slope. Suppose you need to find the deflection at point A, differentiate that strain energy with respect to load at that particular point. You can get the deflection also. That's the two formula we have, my dear friend. Please note down. And this is what this strain energy formula, very important. This formula is there when the beam is subjected to bending. When the beam is subjected to bending. Done, all of you? Perfect. So let me just explain you strain energy first of all. See, we will try to solve the first of all very cantilever beam problem subjected to free end so that you can able to digest A, B. At a particular distance, I'm applying the load. Suppose I need to find the bending moment first of all. What is the moment at this particular cross section? Minus W into X. Minus W into X, my friend. Now, what will be the strain energy for this beam? For the beam AB, mxx whole square dx divided by 2ei. From what? From 0 to L. From 0 to L, my dear friend. From 0 to L. So W into X whole square dx divided by what? 2ei from 0 to L. So W square divided by what? 2ei x square dx from 0 to L. So what is the U value? W square divided by what? 2ei L cube by what? 3. Now differentiate with respect to W because W load is acting at this point B. That is going to give you the values of what? Deflection. Differentiate. So you will be calculating as what? WLQ divided by 3EI. All of your understanding? The same answer you are calculating from third method also. That is what the strain energy method. Yes or no, guys? So this method is very useful when you know the strain energy concept. But this method will be difficult as you can say that now suppose you need to find the slope at point B. For that, there is any moment is acting at this point B. For finding the slope, any external moment is acting at point B. Any external moment is acting at point B. Any external moment as of now, whether it is acting at point B. No. So for this case, first find the strain energy, my dear friend. First find the strain energy, my dear friend, while applying the what? Imaginary moment. Applying by applying imaginary moment. Right? We can find the slow value at the point B by while applying the imaginary moment at the point B. Imaginary moment like this. Imaginary moment we are applying. And after, with the help of that imaginary moment, we can find the slope value, my dear friend, right? So this method will be tough when there's a no movement or no load. Suppose directly this load, this diagram will be given to you. Very easy to find what? Slope at point B, but very difficult to find the deflection because for that we need to apply the some pseudo force or what? Imaginary load, even it is not there. And at the end, after finding the strain energy, put that particular imaginary moment to be what? 0. We will understand this while solving the different problem. As of now, please note down these things. Now we can solve that particular problem, whatever the problem that has been allotted to us. So we can verify, we can cross check whether from the moment area method and from this Castigliano's method, whether answer is same or not. Yes or no? That 14 PLQ divided by what? 81 EI, right? Yes or no, guys? Now, once it is done, let me know. Come back to this problem and let's have the analysis, my dear friend. Come back to this problem and let's have the analysis A, B, C. So total strain energy of the beam will be made up of UAB plus UBC. That is going to be total strain energy, my dear friend. What will be the strain energy BC portion? What will be the strain energy for the BC portion? There's a no movement. There's a no movement. There's a no load at all. In this case, this will be 0, right? Check it out. All of you, please check it out. Perfect. Perfect. Now, try to understand. I'm going to take this section. I'm going to take this section XX. Now, it's up to you, my dear friend. You can take the distance from the point B and point C. You can take the distance from point C and point B, but remember that whatever the section we are taking from A to B, then whatever the bending moment we are going to find, that is going to be valid between B to A only. And whatever the strain energy we are going to find, that is valid between A to B only. Right? Now, suppose I'm taking the moment at that particular cross section in AB portion, sorry, in AB portion of the beam, in AB portion of the beam. In this case, my dear friend, suppose I'm taking the distance x from here, x from here. I'm taking the distance x from here. In this case, what will be the values of this thing? Or we can directly, why to make the integration complicated? Instead of that, we can take the distance from B point only. That would be very good idea, right? So that what we can just find minus P into X. Minus P into X, that is what the bending moment that is going to be acting. And now this section will be valid between what? 0 to 2L by 3. Check it out. This section is going to be valid between 0 to what? Sorry, 0 to 2L by 3. Yes or no, guys? Check it out, all of you. All of you, please check it out. Yes. So now what is the total strain energy, my dear friend? Mxx in AB whole square dx divided by 2EI from 0 to 2L by 3. And this part will be 0. So what is the total strain energy, my dear friend? Minus P into X whole square dx divided by 2EI from 0 to 2L by 3. And this value will be P square divided by 2EI x cube divided by what? 3. From 0 to 2L by 3. So what is the total strain energy? Let me just remove this part. What will be the total strain energy in this case? What will be the total strain energy, my dear friend, in this particular case? Now, the total strain energy we can write P square divided by what? 6EI 8LQ divided by what? 81EI. Check it out. Now differentiate with respect to P. I will be calculating the deflection at point B. Because my different load is acting at point B or point C. Check it out. Because load is acting at points B or point C. Point B. So deflection we are able to find at point B only as of now. Differentiate 2P divided by 6EI 8LQ divided by 81EI. So this is going to be cancelled. So what we can calculate 8PLQ divided by 8PLQ divided by what? 243 EI. Yes or no, guys? All of you are getting my point? All of you are getting my point, what I'm saying? Please check it out. Please check it out. Yes, no down, no down. Do not worry. I know that some of you might be confused, sir. We need to find deflection at point C, but you are finding at point B only. Just wait, hold on. EI square. No, only EI will be there, not square. Because bending moment at that cross section, that we need to do the squaring. That's it. Do not square any other term. Do not square any other term. Now, after noting down, then please let me know. My dear friend, you know that M by I, sigma by Y, E by R. This is what the bending equation we have, my dear friend. Right? This is what the bending equation we have, my dear friend. Right? Now, try to understand. Radius of curvature will be the radius of curvature will be EI by M. Can we write like this? At any portion when bending moment is 0, the radius of curvature will be infinite. Check it out. Do check it out. At any portion, my dear friend, at any portion when bending moment is 0, the radius of curvature will be my dear friend infinite. What is the meaning of this case? What is the meaning of this thing? When bending moment is constant, radius will be constant. We are getting circle. We will be getting circle. When bending moment varies, the radius of curvature will be vary parabolically. But when it is 0, it is infinite. The radius of curvature will be infinite means what? How the elastic curve will look like? How the elastic curve will be look like? Just wait. I'll be coming to that particular point. Just wait. So here this is the elastic curve, because between A to B, the bending moment is varying with respect to x. That's why it is parabola. Between B to C, whatever this particular curvature of the beam is there, that will become a straight line. Now, please let me know those who have not understood this thing. Why it is parabola? Why this is straight line? Tell me, guys. Any doubt? Please let me know. Any doubt? Please let me know. Please. Because these things are very, very important. I know that many confusion you might be having, but please let me know. Straight line. Radius of curvature will be infinite. Circle. Radius of curvature will be constant. But if you just take any parabola, the radius of curvature will keep on varying. That is what we are drawing the elastic curve. Bending moment diagram, shear force diagram, but along with that, you must be understanding the elastic diagram. How the beam will bend. That is a very, very important thing. Now, my friend, once it is done, please let me know. Once it is done, please let me know. At point C, we need to find the deflection. Suppose you are calculating with respect to B, YB plus theta B into L by 3. What will be the delta B C with respect to B? What will be the delta C with respect to B? Big zero, right? Big zero, right? Check it out. Perfect. Perfect. Now after that, what you can just calculate? After that, what you can just calculate, my different. Suppose you have found out this spicy YB value, that is absolutely fine. But how to find theta B value? How to find theta B value? From the moment area diagram. From the moment area diagram, you can just find the values of what? You can just find the values of what? Theta B. And theta B value will be just a area of what? Bending moment diagram. Just area of bending moment diagram. If you just find it out, that will be sufficient to calculate theta B. Half of base into height. And the distance from B to A will be what? 2L by 3. Then what is the total formula of theta B? What is the total formula for theta B? 2 and 2 will cancel out. 2PL square divided by 9EI. That will be answer for theta B. I need to find the answer for YC. How we can find? YB is what? 8PL cube divided by 243 EI. Theta B, what is the theta B? Plus 2PL square divided by what? 9EI into L by 3. Yes or no, guys? All of you can able to follow me? Now after this one, what is the value? What will be the value? Something wrong? See, try to understand. Try to understand 2 to 3 things. Actually, whatever the problem we have solved this particular question, whatever this question we have seen, we have solved this question by the method of what? Moment area method. Moment area method we have taken between point C and point A. Let me check the what is the official answer for this question. Let me just check. All of you are getting 14 PLQ divided by 81 EI. All of you are getting the same answer. All of you are getting the same answer. Let me just check. Just wait. We need to find the deflection at the load at the end of the beam. Yes, that is correct. 14 divided by what? 14 divided by 81 PLQ divided by EI. That is the correct answer. Now I need to get the same answer by strain energy method also. That is what I was actually trying by different method also. Understanding my point or not? All of you are understanding my point? You should be getting exactly the same answer by all the methods. Of course, you can try this method because this is very simple method. Whenever the cantilever beam is there, you can just try it with this method only. Whenever there's a cantilever beam, because that will be a very easy case. But I just want to know whether you are getting the same answer with respect to Castiglione's method or not. Okay, leave apart from this side as of now. You can try this question by Castiglione's and let me know. Whenever we have the next class, please let me know. By strain energy method, are you getting the same I explained you the how to find the strain energy and how to differentiate with with respect to the loading condition, and then you can get the what deflection. But you should be getting the same answer, right? You might have done some mistake in the calculation. We will check it out. Okay, so next problem will be this one. Try to solve this one. A cantilever beam which is a point B and point A is there. At the end, we are just subjected to concentrated load and concentrated moment is acting. They are asking what will be the deflection at the free end. What will be the deflection at the free end? I will be explaining this problem by method 4. Superposition method, because that will be very simple method. Superposition method, very important, please note down. Once it is done, let me know. Superposition is saying that, my dear friend, superposition principle is saying that whenever there is a cantilever beam, suppose not cantilever beam, any other beam, it is subjected to the load point P, and suppose moment also, this particular thing we can resolve in two ways: load plus moment. Whatever the deflection 1 from here and deflection 2 from here, total deflection will be simply delta 1 plus delta 2. But there's a condition. When you just load it, in all the case, the deflection will be downwards. Suppose the loading condition you might have given something like this. In this case, because of this P, there is a downward deflection, and because of this moment, there is the upward deflection. In this case, the net deflection will be delta 1 minus delta 2. Understanding this method? Understanding this particular method or not? All of you are understanding my point? So here, because of the point P, what will be the deflection? Because of the point load, what will be the deflection? Let me call delta 1. P, suppose length is what? L. P LQ divided by 3 EI. And whatever the deflection 2, because of the movement, because of the external movement, will be ML square divided by what? 2 EI. 2 EI. So total deflection will be at the free end would be, total deflection at the free end would be what? P. So can we try by the Castigliano's method? Can we try this by the Castigliano's method? All of you are very much interested. I will tell you the shortcut. Do not worry. Do not hesitate. All the methods are very simple, very straightforward. But why there is a confusion? Because of this some calculation mistake we might have done in that particular problem, right? Let me explain you this particular problem. We will be getting exactly the same answer, right? Shall we solve it? All of you have noted down? All of you have noted down? Yes. Yes. All of you have noted down? Perfect. Try to understand. Some of you might be having some hesitation, some fear about this Castigliano's method, so it's a very difficult method. Let me tell you the shortcut. So method 3, I am explaining this problem by method 3. There is a point load, there is a moment. Again, I am saying that in the problem, those apply the method which are very simple to the given problem. Do not try to be over smart in examination. Suppose you know 4 methods. Now you will say, I will solve that particular problem by all the 4 methods in the examination. That means you are fool. You are going to invest a lot of amount of time, and that is unnecessarily time you are going to waste it. Try to stick with the method that is very simple. Suppose cantilever beam, try to stick with the moment area method. Suppose simply supported beam, try to stick with the what? Castiglione's method. Suppose any other simply supported beam is there but unsymmetric loading is given, try to follow double integration method or Macaulay's method. That I will explain. Do not worry. Now, so total we have 5 methods, my dear friend, to find the slopes and deflection. Now, take the moment according to strain energy for whole beam. For whole beam, you know that what is the strain energy of the beam? Mxx at that particular cross section whole square dx divided by what? 2ei. And that distance will be what? From 0 to L. From 0 to L. Now, my dear friend, what is the moment at xx distance? What is the moment at xx distance? Minus p into x. Some of you might be thinking, sir, it will be difficult for us to solve this problem. I will tell you the shortcut. And again, minus m also. Again, minus m also. Now, shortcut is, anyway, you are finding the deflection and you are differentiating with respect to that loading conditions. That loading condition which are acting at that particular point. Yes or no, guys? Anyhow, you after finding the strain energy, you are differentiating with respect to the load that has been acting at that particular point. Understanding my point? Check it out. This is statement, whether it's clear or not. Perfect. Perfect. Calm, cool, relax. Now, what you do? YB will be integration 2mx into dx into dou mx divided by dx divided by 2ei. Nothing I have done, my dear friend, just I have differentiated with respect to x so that I can find the deflection. Anyhow, sorry, just wait. Not with respect to x, we need to differentiate with respect to p. We need to differentiate with respect to p. We need to differentiate with respect to p. All of you understanding my point or not? Check it out. Right? Or instead of that, to avoid the confusion, I can just stick to the method. Afterwards, we will see the shortcut. Because first of all, you must be familiar with the method actually. So instead of just jumping toward the shortcut, let me explain the full method. Mxx will be what? This particular thing. Now, anyhow, you are differentiating this thing. Now, if you just differentiate d by dx, d by dp of this one, if you just differentiate, what you will be calculating? If you differentiate with respect to the load condition, what you will be getting? What is the, suppose you are calculating dx by d by dx of, suppose, y square, then what you do? 2y into dy by dx. Check it out. Yes or no, guys? Or instead of that, no, let me just explain you simple method only. Castiglione's full method, let me explain you. After that, we can see the shortcut. Otherwise, you'll be confused. Now put the value in the formula and try to find the strain energy. Into dx divided by 2ei from 0 to L. From 0 to L. So strain energy will be a plus b whole square will be what? A square plus b square plus 2ab plus 2ab. Check it out. All of you, please check it out. All of you, please check it out. A plus b whole square will be a square plus b square plus 2ab. Check it out. Minus a square will become what? Plus. Minus 1 square will become what? Plus. UAB will be p square x square divided by what? 2ei from 0 to L. M square dx divided by 2ei from 0 to L. And after that, my dear friend, after that, my dear friend, it will be 2m px divided by 2ei from 0 to L. So UAB will be p square x cube. Directly I'm writing the formula. Directly I'm integrating, I'm putting the limits. L cube divided by what? 6ei. Please check it out. Please check it out. All of you please verify whether it's correct or incorrect. All of you please verify it whether it's correct or incorrect. Whether it is correct or incorrect, all of you please verify it. Please check it out. Correct or not? Correct or not, guys? Please check it out. Yes. Sorry. Yes. Perfect. 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 After that, what you do? We need to find the deflection. We need to find the deflection dou UAB divided by with respect to P. Differentiate this thing with respect to what? P. When you differentiate, you will be getting 2p. P square will become 2p. P square will become 2p. P square will become 2p. LQ divided by 6ei. This is gonna be 0 because dou m by dou p will be 0. Dou m by dou p will be simply constant. See, m is constant with respect, m is not containing any term p. So differentiating with respect to p will be 0. That term will be 0 plus differentiate with respect to p. Differentiate with respect to p, you will be left out with m. L square divided by 2e. Check it out. All of you are getting the same formula or not? Check it out. So I said you all the problems will be solved by all the 5 methods, but some method will take 2 minutes time, some method will take 0.5 second time, some method is going to be take 10 minutes of time, some method will take 20 minutes of time also. So for the individual problem, we have separate method that is made for what. But if you understand all the 5 methods, each problem will be solved by all the 5 methods. And that particular research work you can do for the GATE examination or for the HL examination, right? Here we need to simply remember the formula, that's it, right? All of you understanding? So we will discuss about the strain energy in the next class, more detailing about the strain energy. Along with that, we will start principal stress and strain along with the Mohr circle. Then after that, in the last class, we are going to cover this thin cylinder, thick cylinder, and what columns, right? Understood, all of you? Correct. So just complete it, then we can leave for the day. All of you have noted down? All of you have noted down, right? Correct. Okay, guys, thank you. Yeah.